So now same thing, if you go for an FM signal generated by VCO, the baseband voltage becomes more positive and the output frequency will increase. FM signals are not symmetric. So when you pass the signal to an FM generator, you will see when the frequency variation is less, the VCO output is less. When the frequency variation is more, the output is more. So if you take the midpoint, the carriers are not symmetric. Okay, in AM it is symmetric, but in FM it is not symmetric. It is going to be dynamic. So the FM signals have an asymmetric spectrum, and most of the modulation schemes also have asymmetric spectrum only. So while the conceptual diagram theory always we stress about symmetricity, but in practice all the modulations are asymmetric. So that is how you have to handle them. So as an exemplified by the spectra, down conversion will lead to zero IF, superimposes two copies of signal, thereby causing corruption. Signal spectrum is asymmetric. So asymmetric spectrum will cause signal corruption. See, this is going to be one IF IFM signal. And then definitely this is, if you take the mirror image, it is going to be this signal. When you add these two signal, you get these two, the signal like this. When you superimpose these two signal, you get a signal which is going to have two peaks and two lower order peaks. That is, when you add these two signals frequency by frequency, you get this. So this figure depicts this effect more explicitly. How can the down conversion to a zero IF avoid self-corruption? So when you mix these two signals, the resulting signal does not resemble your omega IF completely or omega minus omega IF1 completely. It resembles addition of both, which means that the signal itself is corrupted by noise. So sometimes when you do a 0 second IF, the signal and noise will be there at the same frequency. The perfect example is FM. AM la varadu because the spectrum is symmetric, right? But in FMs, when the spectrum is asymmetric, we have this issue. The image and signal sitting on the same frequency. So definitely you should have mechanism to reject the image and take the message alone. So this can be how to do that. This can be accomplished by creating two versions of down converter signal which are phase shifted by 90 degrees. So take your signal, multiply by LOs which are 90 degrees apart. If for one LO I'm going to use cos, for other LO I'm going to use sine. So I have in phase, I have quadrature phase. So in the figure, the quadrature down conversion is performed by mixing the IO with two LOs. And you know the understanding omega LO2 equal to omega IF1. This is the concept of 0 second IF. Instead of mixing only once, I'm going to take the same signal and I'm going to mix it twice with two LOs, and the two LOs are 90 degrees out of each other. And resulting, I'll get in phase and quadrature phase. What I'm going to do with that?